Okay, hello everyone. We're ready for the second half. I'll be super short since, as usual, I'm going overboard with the duration of everything. But there we go. It's Rock Solid Platforms in Zig by Lucas. You saw earlier a trick question about whether you can build a project that has both Rust and Zig in it. And turns out there is already an answer to this question. And I think that now Lucas is gonna show us. So Lucas, the stream is yours.
Cool. So yeah, the talk is rock solid platforms in Zig. This is the Rockbird and the Zig mascot. So let's just get into it. A little bit about me. This is the least interesting slide. So as soon as the sentence is done, I'm moving on. But these are the social links if anybody wants them. So this is what we're going to talk about. We're going to talk a little bit about what rock is, right? So what's rock? It's going to be mostly some hand waving at the syntax and just to get a general idea of like what it looks like. So you're not super confused by the time we get to the demo. And then before we demo, we're going to talk about how rock uses Zig. And there's two sort of main ways. So let's go. What's rock? Here's a useful URL that anyone can go to if they want to learn more. Just going to link to another video with the original creator sort of talking about it and then giving an email where you can sort of reach out if you want to contribute. And so Rock is a pure functional programming language. It's built using Rust and some Zig. So thanks for the setup there. And then there's LLVM involved, there's reference counting, and the language is immutable, except if you have some data that's uniquely referenced, it's safe to mutate in place, and that will happen, which has good implications for performance. So let's look at a little bit of code. Rock has lists. Lists are more like arrays. You access with list.get, you update with set, right? And so on the right here, we have some code, right? And we're defining an add one function, right? Takes a number, returns a number. And you can see the lambda syntax here. We're just going to take a plus one, nothing too complicated. And then we have some data, which is just a little num. And then we're going to some pipe syntax here. And the language is a descendant of Elm. So there's a lot of syntax similarities there, right? And so we're just going to pipe data to list.map. We're going to map add one over that. And then we're going to reverse the list. And then we're going to list.get one. So we're just going to get index one, which technically there's no point in reversing the list anyways, because one is the same. It's an odd numbered list. But yeah, that returns a result. And so we can pattern match on that. And we'll sort of talk about pattern matching a little bit. Rock also has records, kind of look like JavaScript records, supports punning. You can pattern match on exact values, and there's optional fields. And so this is what some of the code looks like for working with records, right? Have a variable, and then we're creating a record mascot with a name field and an email field. And then we have sort of update syntax, which deviates a little bit from Elm. And then we have some field access, mascot.name, and then a sort of cool way to do some field access with the list.map there. And then we have tag unions, which are pretty much like algebraic data types, but like they do more stuff. They support exhaustiveness checking. There's pattern matching on them, right? And they don't need to be declared before they're used. So there's some similarities between polymorphic variants and OCaml. They're not the same, but feel similar sometimes. And so on the right here, you have at the top a cons list. It's a standard little algebraic data type. So that's us using a tag union as a traditional algebraic data type. And then lower, you have some more fancier kind of usages where you can kind of compose them and like the errors merge. So you have like this file open error, right? And notice that the A is at the end of the brackets, not being used in any of the constructors, right? So in file write error, we can actually have a whole nother tag union kind of be that A, and then all of these constructors kind of merge into their own tag union, which is file write error. So that was just some brief syntax so that people aren't completely confused when we demo, right? So how do we use Zig, right? So a bunch of the built-in functions in the standard library are written in Zig. And the way we do that is we will compile the Zig code into LLVM-IR. And then on the Rust side of things, we're using a library called Inkwell. And then we'll sort of stitch everything together like that. And then another way you could use Zig with Rock is this sort of has to do with the way Rock is designed. And so Rock programs are always going to have sort of two parts, right? An application and a platform, right? And platforms are sort of how I/O is done in Rock, because otherwise the Rock language doesn't have any I/O, right? It's always provided by some kind of platform. So let's talk a little bit about apps and platforms, right? So as a Rock application author, you would pretty much only ever write in Rock. I mean, it's up to you, but you only need to write in Rock is the point. And then platform authors will likely use some kind of systems level language. Could be Rust, could be Zig. That's why we're here. And it could be C. As long as it speaks the C ABI, it should be fine. And then they'll probably write in a little bit of Rock too to expose sort of nice API from the platform. And so what the compiler does is it'll compile the Rock code and then link a pre-compiled platform together. So it's not like FFI or anything like that. And then, every Rock application must have exactly one platform, and we don't provide a default platform. One must always be picked. So let's just demo now. Just look at some code. Cool. So I already have open here, like it's kind of like an example of what a sort of Rock application would look like, right? And then you kind of have like the main here, which would be like the Rock application entry point. And then conveniently located, we have a platform folder adjacent to that. And we're going to start there and then work our way up. Right. So the first thing you kind of see here is this package config.rock. And this is sort of just like the configuration file for the package, right? And so you have a name for it and then requires. And this is pretty much saying the application needs to provide this to me, the platform, right? Some exposes, we're not using these packages, and then we happen to import task from the task module, which is right here in the platform. And then this is some wiring together. We're not going to look at this too much right now. We're going to focus more on effects, right? And how we implement an effect or some I/O in Zig, right? So this effect thing is provided to you by Rock. So that has functions like effect.map, effect.after, stuff like that. And so let's say we want a new effect, right? So whatever we define in here will be sort of injected into effect, and then we can use it in all of these other files like file.rock, path.rock, task.rock, right? So let's add our own, right? Let's do something for like writing to a file, right? And this is going to take like some string, which is probably going to be like the path. Or the file name, right? And then another string, which would be like the content of the file. And then it's going to like return some effect that's wrapping a record that just has like a sort of useful error code that we can then, as a platform author, pattern match on, and then return a proper error like tag union. Cool. So that's that, right? And now we actually need to implement this, right? Also notice that nothing's curried. So we use commas here to separate the arguments and function definitions, which is a little bit unusual for like ML style languages, but I think it's cool. And then let's just go right into it. So on the Zig side of things, we have this host.zig file. There's a couple other things that happen here, and there's some wiring involved with the main for host, but we're not going to look at that right now. Let's just start defining the function that we just said exists inside of the package config. Right, and so right, all UTF-8, I think is what I called it. And then that takes, what was it? 2 things, right? Yeah, 2 things, and it's going to return this like record thing. Okay. So let's do that. So I don't know, file path. And then that's going to take like some rock stir thing. And then we have like the content. It's going to also be some rock stir thing. And so we need the calling convention to be C. And then we kind of want something like this, right? So we want some like a right result. So we'll just pretend like that exists for now. write result, and then, okay, cool. And so let's define that. Oof, can't type. All right, cool. All right. So it's kind of like some boilerplate there, wiring it together, right? And you see it takes a stir, returns this record thing, and so does this, right? It takes a stir, and then returns some result, which is just, this is going to be sort of mapped to the record. So let's just use the current working directory just to keep stuff simple. So, ooh, little ZLS action. Nice. Okay. And then from there, we could just write file, right? And then so I'll say file path dot as slice. And we have the content also as slice. Yeah, cool. And then that might fail. So let's do something about that. And then let's just be generic for now and sort of like just catch everything inside of this else. I know I could have just immediately returned, but this is good for now. And we'll say like 1, right? Yeah. And then if it worked, we'll just return a 0. So then we'll say no 0. Whoops, I did something bad. What did I? Oh, right. Cool. So that's that, right? And then that'll pretty much get wired together and sort of represent this, right? And so now within these rock files, I'm allowed to reference this function from within the effect module. Okay. So let's actually use it now, right? So let's go to file.rock over here. And let's start implementing it, right? So this one, we don't want to name it the same thing. So let's just get rid of all. And then this is going to take a path, take a stir, and it's going to return some task thing. We don't really care. So it's like returns void pretty much. And then we have some file write error, right? Which already kind of exists in this file, like up here. I promise. Here it is. All right, and this is using like the tag union stuff. There's some cool tag union merging going on here. And so you see we can kind of put another one in there, right? So we'll kind of make up our own on the fly here without defining it beforehand, right? And so that would be like, I don't know, maybe a bad thing happened, right? And then it's open. Cool. So now let's actually fill out the body of this function, right? So take the path, take some data, which is the content, right? Arguments separated by commas. And let's use the pipe operator. So we're going to say path dot to stir. That's just some stuff that's already available for us. And then effect, right? So if you notice, we imported that, right? FX effect, right? So we could use it. And we had a name for it, right? That was defined here, implemented in Zig, and now we're going to call it in Rock. And, you know, sort of this pipes is the first argument, so the pipe goes to the first argument, right? So here, and then we get the stir back, so it's the first argument. So the second argument of that is going to be the data, actually write the thing. And then lastly, let's effect.map, so we can actually pull out the wrapped record. And then we can say when res dot error no is, right? It's like a case of. And so what could it be? What was it? We could return, okay, so 1 is bad, 0 is good. So let's say if it's a 0, you say like okay, and then in that case, it's kind of just like return unit pretty much. And then let's just be exhaustive because otherwise it'll complain that we didn't match on every single number that exists, right? So shouldn't do that. And then our little thing that we made up out of nowhere, right? So bad thing, something bad happened. And so now we could use this Zig code and we have like a sort of cute sort of API around the actual Zig function that we defined. So let's do it, right? And so now this is an app, right? This is, so you have your app name. This will be the name of the binary that gets generated. There's already one right there. Let me actually delete that, prove that I'm not lying. And then we have some packages, right? So we say base, and you can name this whatever you want. As base is just kind of the convention that we have. Comes from platform, which is right here, right? And then we're going to import some stuff, right? And we need a few more things in here, right? So we're going to import base.file, right? We were just in there, and then base.path. We didn't look at that one, but we need it. And then let's just rock, right? Let's do this. So when, and then we say path.from stir, and then I don't know, we'll name the file whatever we want. And then if that's all good, this is actually mocked, didn't really do anything. Yeah, and then let me do one more of these, and then here we'll say like something like task.putLine. So there's actually some other effects available, right? And we didn't really look at those too much, but we see that in here there's something called putLine. So in task that's like wrapped and available for us. So we can say task.putLine, and in here we'll say something like invalid path, right? Okay, that's good. And then, so let's just, so we have this thing called like reverse lambdas. I don't really want to talk about it too much. Sorry, but they're just, it's not, it looks like do notation from Haskell. It's not though. So don't any Haskellers come after me, please. And then, yeah, so let's just kind of like update on what's going on as the program's executing, right? So we'll say like writing to a file. Cool. And then let's actually write to a file. Some more backpassing stuff, right? It's just a reverse lambda. That's all it is. And then it wasn't this one, it was this one, right? And then, so at the path, right, we're gonna write, it's showtime. Cool. And so this is it mostly. Now we just need a sort of like handle on this result, right? Some possible things that happened. So for example, we could say, okay, and then that returned like unit pretty much, so we just don't care. And we'll print out success. And then we had that cool little custom error that we defined on the fly. So we'll handle that just to look cool. Bad. And then, I don't know, a bunch of other stuff might come through. So we're just gonna ignore it. And then, I don't know, this is really bad. Cool, I think this is it. I think this should work. Right, so let's run this. Right, so we have the package config, right? We sort of defined an effect that's available, and that needs to come from the host. And so we have host Zig, right? And you see there's a little prefix here, right? That's important. And then we have the file.rock, which is where we actually use it. Oh, whoops, that was dangerous. Would have been embarrassing. You got to export this thing. Wow. Okay, we're good now. Good thing I reviewed. So, yeah, cool. I think this is good now. And then this is, you know, the little thin sort of API that we expose, and then this is an actual sort of application level usage of this, right? So let's see if it works, right? And then to prove that thing.txt doesn't exist, cool. And there we go. Look at that. And it's showtime. So that's the demo. That's how you can build a platform for Rock and Zig. And before we sort of close things here, let me give some shout outs. So yeah, creator, super big contributor. He's helping with the editor. So we are actually working on an editor, which is, so it's cool that that came up in the previous interview. And it's going to be baked into the compiler. I'm not going to run it because I didn't clear it by anybody. But yeah, and then obviously a bunch of other people that have helped a lot. There's some names that I didn't put here. I apologize. Hopefully nobody's mad at me. But yeah, that's the talk. That's the show.
Thank you very much, Lucas. So let me bring up my camera so people can see me. Let me make you big. Okay, now you're big. Maybe.
No questions. I refuse.
Why? Really?
No, I'm kidding.
So first of all, thank you very much. On point presentation, like you were super fast, and you're not like me. I'm sorry, I'm bad. So I have a couple of questions. In the meantime, people in chat, if you have questions, please ask them. I think. Do you think it's safe to say that we can make use of Richard in chat, and maybe we can have some questions also for him? There's also, I believe, not just him, but also let me scroll up.
Chad is also in there too, I think.
Oh, okay. So there's okay. So we've been raided by rock people. Okay, so they're all rocking in chat.
Yeah, let's go.
Okay, awesome. So I would say it's safe to say that if they also have a take on something, they should feel free to answer.
Just ask them. I have no idea what's going on.
No, you have to go through the questions. I'm sorry. Okay, so okay, when people type questions, so how did you discover Zig?
I don't know. I think it was late 2019. I just like super obsessed with languages ever since I learned like Haskell in college. And then, sort of the languages I was using professionally for like day job stuff was never really satisfying me, right? So I always just kept exploring. I was just like that dude on the team, like, hey, have you guys heard of this? Hey, have you heard of this? And everyone's like, okay, cool, but we got to get some tickets done, So I just always had this sort of like natural attraction to like learning and looking at different languages. And then, you're always just curious, like, okay, like Rust is cool, but like, is there more? Like, what if I want to get even closer, right, to the metal? Not that you can't do that with Rust. I'm not trying to slander anything, right? But you sort of get curious, right? Like, what else is possible? And I think I saw like a video. No, I was on Reddit, just like looking for systems languages, and somebody like replied in a comment, like, "Oh, there's this Zig thing." I was like, "What's this?" I clicked the link. I saw the website. I was like, "Okay, this is cool. Like, simple website. I like this." Learned the language like in a day, which I also really liked about that. I think there's a lot of power in sort of having a language that's really easy to learn really fast. And then that was that. I didn't touch it for a little bit, and then I was like, I kind of saw some streams and videos from Andrew, of course, right? And I was like, this guy is amazing. Like, he's hilarious, he's cool, and I like this project a lot. So I'm in, right? And I sort of really bought into it after seeing Andrew. And then I was like, okay, let me build a little thing. So then I built like a little like Lispy like calculator. It's on my GitHub. Just to like have some skin in the game. And if anybody asks, it's like, no, I built the thing, trust me. And then, but it's super simple, and don't look at the code. You probably, I'll get embarrassed. But that's pretty much how I found Zig. So, and this was all like late 2019, early 2020 for me. And then just sort of being in Discord and following along. But yeah, that's sort of my intro story to Zig.
I see. And one day you joined voice chat.
One day I joined voice chat. That's right. That's right. And then it was cool actually. I don't regret that. That was nice. Everybody was nice. Everybody was welcoming. And I wouldn't be here if I didn't randomly join that voice chat. So yeah.
Awesome. I guess I should ask you also, like, in a sense, the inverse question, like, how did you discover rock?
So I had my own ideas for a programming language, right? Very naive ideas. I'm not in any way super talented at this stuff, right? I'm trying to get there. So I was talking to my friend Brandon. He actually is the maintainer of Ellie app, the sort of web-based editor for Elm. He didn't create it. It was, I think Luke, handed it over to him to maintain. I forget the exact details, so apologies. But I was sort of ranting to him, right, in text messages, like, "Oh, I want to do this, and it'd be cool if I did this, and it'd be cool if I did this." And he's like, "Oh, did you know that, Richard's building a language?" And I was like, "What do you mean? Why don't I know about that?" And so he gives me a YouTube link, right? And the YouTube link is linked at this website. So go and please check that out. And he gives me this YouTube link, and I watch it, and I'm like, "Oh, this is really cool." And then at the end of this talk, that's linked here, he gives you an email address that you can reach out if you want to try it out and sort of participate. The repo is currently private, mostly to avoid virality, and there's still a lot to be done. So we want to just make sure stuff is nice and ready before the masses come to it, if they do. And so I emailed that email address, right? Sort of gave him a speech about my useless ideas and how I'd like to sort of be mentored and learn from everybody involved with the project. And he's like, "All right, come right in." So I get added to the Zulip, and then from there, I just kind of kept harassing everybody for like help with my pull requests, right? And it's just like one pull request led to another, led to 40 of them now. I don't even know. And so, yeah, sort of everyone does a lot of pairing, and it's just been fun. Everybody helps each other out a lot. I was mildly familiar with Rust. I mean, I knew what it was for quite some time, but I'd never built anything serious in it. So, there also was some learning Rust as I sort of participated more and more. I haven't read the book yet, but maybe eventually, right? So for now, the way I do it is like if I run into something I haven't used before in Rust while I'm working on the compiler, I just go to the book and then look up that section then and there, right? Which is actually something I think Togglebit recommended people do, right? Don't even waste time reading the whole book. Not that it's a waste of time, but like, just start using something and then like look stuff up as you need it, right? But yeah, that's how I got involved in Rock, right? I sent an email to an email address and they were nice enough to let me participate.
Interesting. Awesome. So I am a bit confused though. So you said that you want to prevent virality, but then you go on an internationally acclaimed show like Showtime. I mean, there's like a grand total of almost 50 people watching these right now live on Twitch. I mean, this is gonna go viral tomorrow, maybe even earlier than that.
Right. Yeah. So I guess we're screwed.
That was really bad planning on your part.
I know. I blame Richard. He gave me permission.
Okay. Sounds cool. Okay, there are a bunch of questions, but I'm gonna hoard the question floor before I go through any of those because I have a couple more that I want to go over. So, I was seeing in chat that Richard was saying that there are no algebraic data types, I believe.
Right. That was just an analogy.
Yeah, so you don't have a precise algebraic data type for monads, and you also showed that there is no standard carrying syntax. Can you do built-in carrying? Or
No.
no? Okay, so here's the question then: why do you people hate monads? Maybe you have good reasons. Actually, I don't know much about programming.
Don't you hate monads too?
Maybe I would if I knew what they are.
Well, then joking. That's my answer. Because okay. I don't think I understand what they are either. I mean, maybe I do, maybe I don't, but I mean, for the most part, I mean, Elm doesn't have them, right?
Mhm.
And so this language is a descendant of Elm,
Okay, I see.
and right.
Oh, maybe we can give a chance to Richard to answer that in chat. So I would guess the question, if we were to pose it nicely, would be so monads, I guess, are nice but not fundamental. Probably you can pull something off. Like you can surely implement the same logic one way or another. But I'm also guessing that if you don't have built-in carrying, they become kinda so unergonomic that you don't want to do that. So my guess is that the language kind of wants to push you away from that way of doing things.
Right, right. And I mean, and the language itself has no IO, right? So it's like, do we even need that, right? Like if the IO is coming from a platform, we just have this sort of like effect thing that wraps everything. And then we have like methods for sort of unwrapping and getting access to what's inside the effect.
Mm-hmm.
Which,
Okay, so
yeah.
Richard wrote in chat that Rock wants to be a simple language like Helm. Okay, that's
Oh,
a sentiment that we can get
yeah.
behind.
Cool. Yeah.
Awesome. Okay, final question from me then. I'll open the floor to all others. It seems to me that we should have in the Zig, from the Zig side of things, a library that automatically takes error sets and Zig error sets and produces CABI stuff. And probably there should be something on the other side that automatically takes CABI stuff and binds them to nice rock errors. Does that make sense? Have you people had already a thirst for this kind of like nice library to automatically ferry stuff around?
That would be cool, especially in the example I just showed, right? So, because we do some kind of like catching here, right? And so like, we do have like the error dot stuff. So it'd be cool if like there was just like a one-liner that can convert the whole set to something that's like understandable on the other side. If that's what you meant.
Yeah, that's kind of what I was going for.
Yeah, we haven't dug into that, but that would be cool.
Awesome. Okay, let's see the questions.
Yeah, I can't see chat, so you got to ask them.
Yeah, no worries. That's so with interviews, the person interviewed can see chat, but I think when with talks it's easier if I do that for you. So why write a platform in Zig while everything else is in Rust?
What's in Rust? The compiler?
Yeah.
Is that what you mean?
Yeah, I mean the rest of the language is implemented in Rust.
I don't know. Like, it doesn't matter, right? It's the CABI. It doesn't matter what you write in it.
That's a good point.
I don't know, right? Like, I don't know. Maybe you don't like Rust, so you're not forced to use it. Or maybe you have some. I don't know. Maybe you want to write the world's fastest HTTP server in Zig, and expose that as a platform, right? So I don't know, and that's kind of the point of having the platform be swappable, right? If you don't like it, you could just, I don't know, you can write one in Rust, you can write one in Zig, and so maybe that, I don't know. I'm not trying to avoid the question. It's just I'm not sure the question is like.
I think I understand the point.
Like,
I think I understand what you're trying to say. Like, the point is that maybe like the reality is that platforms are not an integral part of the language. The point is that they're swappable. So not everybody is going to write platforms, but writing platforms, it's not something entirely up to the core core Rock maintainers.
Right.
I tomorrow can write my own platform and I use whatever I want as long as it can do CABI.
Exactly. So I don't know, right? Yeah. So in terms of why would you use like Zig versus Rock, it just depends on what your constraints are, what setting you're operating in, right?
Okay, let's see. There was another question about, is this aimed in the same space that Haskell is in too? Is it slightly different? Maybe somebody answered this one. Do you want to give your opinion on this?
Well, I mean, yes, in the sense that it's a general purpose programming language. No, in the sense that we're not particularly interested in being like academically pedantic.
Okay.
right? Yeah, and that's not to throw shade or anything like that. Haskell's a perfectly fine language, but yeah, it is general purpose, right? So ideally for anything.
Okay. Yeah, there was also an answer by Chad.
It's pretty fast too.
There was an answer by
Fast.
Chad that was in chat, and I think maybe it's worth repeating that the idea is that it's more flexible if you can swap in and out platforms. I don't think you can do that with Haskell, right?
Fair enough. Yeah. Yeah. Absolutely.
Yeah. So let's see. Is WASM supported?
Um, like compiling like Rock to WASM,
Mm-hmm.
like or like running the Rust compile the compiler that's written in Rust as like WASM.
I think it's about writing a Rock application like what you just wrote, but like as a WASM module, and then have it run in WASM time or something like this.
I mean, we do use LLVM, so I mean maybe there's like some way to like rig it together, but it's not like anything we've tried yet or
Mm-hmm.
anything like that.
Well, maybe I can answer this question as an outsider. I guess you can totally write your own platform layer that implements WASM stuff. You can compile to WASM bytecode through LLVM. Maybe there are some other details, but I guess the next big question would be, can you implement allocators in the platform layer? I would assume yes, but you didn't show this.
So if you see this tab here,
Yeah.
there's some conversation around that, but that's all some fresh ideas. So I'm not going to open that right now. This actually accidentally opened right now.
Mm-hmm.
So there's some talk about the host controlling memory allocation, which would probably play really well with Zig platforms actually. But I think these are all fresh thoughts.
Okay.
It's not like off our radar. It's definitely
Mm-hmm.
on the radar. Not that we're going to do it, but it's in discussion.
Okay. Yeah, makes sense. WASM is a bit of a peculiar platform. Andrew said, what is it? You have a badass tattoo.
Which one? Oh, the neck tattoo. Yeah.
Yeah, nice.
Thanks. I also have like hand, forearm ones. Thank you.
So this is another question by Andrew. Other than 8218, which I don't remember which issue that is, what are some things that we could improve on Zig's end to make Rock development smoother? So let me go find out which issue is 8218 because I don't remember.
I think it might be the compiler RT issue. Though that seems super old though. It might not be at all.
I think you're totally right. I have compiler RT.
Cool. Yeah. So it is that one. I don't know. I honestly can't think of anything. I think Fulkert might actually have some suggestions because he's in there a lot, sort of heavier. But I can't think of anything. I think it's great. So
well, I think maybe this is not like a Zig theme, but like a Zig library to ferry nicely error codes over the CABI. Right. That would be cool. I think.
Yeah, 100%. But yeah, off the top of my head, I can't think of anything that I would like ask there to be in Zig to make our lives easier. Maybe there's something, I just can't think of it.
Okay, then there's Richard calling you a very modest and also great contributor. Oh no! Oh wait.
Thank you.
Okay, no, there's crypto code. There's crypto code suggesting to call. So the language is Rock, and so the package manager should be called roll, so you can rock and roll.
Oh, cool! Like maybe you do like a rock roll update, and then all your packages update. Rock roll, and it'll be like a sub command on the compiler. That's actually cool. So thinking of like names for things, and this is sort of me petitioning. I tried to name this bird, and nobody liked it, and I was sad. So the bird has no name. If people want the bird to be named, rage in the chat, please. I'm sorry, Richard.
Okay, so let me read a couple of comments that so that they survive the YouTube video. So we also use Zig in the compiler itself to generate code for your built-in functions, like list.reverse and such. Right. So
Yeah, exactly.
okay, so Zig is also used there. Well, I'm curious to see then why are those not in Rust? Not that I'm complaining. Just
Right.
curious.
So the reason is that we would have to do it in Inkwell, right? So it's like we have to generate the LLVMIR and we use Inkwell for that. And actually just writing the logic for what gets generated in Zig is way easier to read
Mm-hmm.
than some sort of like Inkwell DSL. Inkwell is a great library, but just a plain programming language is a little bit easier to read. So it's like we can see like in Zig, like, okay, this is going to turn into this LLVMIR versus like, some like Inkwell, like builder dot like build aloca, build store, right? And then it's not as sort of, I don't know how to describe it, but it's just easier to read in Zig and then turn it into LLVMIR. And then we hook it back into the Rust side with Inkwell and stuff like that. We'll just call bitcode functions.
Mm-hmm. Right. Okay, these were messages from Folkert. Chad also said, I think this is an interesting comment. As I sometimes think of it, there's a whole gradient between code that I wrote in this one spot and the programming language itself. So these two being the two opposite ends of the spectrum. And with framework and external package and module being intermediate values. And Rock is carving out a new level, kind of in between programming language and framework, and calling it a platform.
Mm-hmm. Mm-hmm. That's really cool, actually. That's a good way to describe that.
Yeah, I think it's interesting for portability reasons. I think it's a very different take compared to what Zig thinks of portability. Like in Zig, you compile everything down. Well, no, I guess it's the same because everything is compiled also in Rock. So okay, that's cool. That's a very different take. Like the end result, I guess it's the same. It's a native binary, but it's a very different approach to this kind of stuff. Cool.
Yeah, and then we have some cool sort of like sort of optimizations, right? The reference counting comes from this paper, Counting Immutable Beans, and then there's actually a Coca, and there was a paper they dropped in November 2020 for Perseus, and Folkert actually read the paper and took some stuff from it, and so that's in Rock, I think, already. And that has to do with the in-place mutations, right? So if you have some unique reference to some data, it's actually safe to just mutate the thing in an otherwise immutable language, right? So it seems like we're getting some good speeds from that too.
Okay, sorry, I'm reading down stuff. There's a bunch of discussion since there's so many Rock people in chat. I just want to make sure that those survive for the YouTube video.
Sure, yeah.
Okay, so apparently Richard has been radicalized too. He says in this comment, I didn't realize it until recently, but yeah, you can control malloc and free from the platform. And that's the Zig bug in your brain now. You can't escape from it.
Maintain it in Zig.
Yeah. So, okay, so the language will include the package management features rather than having a separate package manager. I think that's a great idea. Oh, also like Elm. So Elm does that too. Okay, that sounds awesome. Okay, question. Do you think it would be a reasonable use case to use Rock for a video game with the platform layer being the game engine and Rock code having the role of a scripting language that that a scripting language would traditionally have?
Yes, absolutely yes. Right. So yeah, you could write the whole game engine and all of the sort of performance critical parts as a platform, and then expose, right, like a sort of a much nicer, cuter API from the platform. So then you have a game engine platform now, right? And for Rock, and then you could just use Rock, which is much more higher level, to sort of call into all of these sort of underlying platform functions and features. So yes, absolutely yes, and hopefully, I would like to see that sort of be like a nice, robust sort of corner of the community in the future.
Yeah, that's very interesting. Oh, oops, I did a mess. Yeah, that's very interesting. I People are also kind of comparing this way of doing things to Lua and Tickle, which I think is another interesting thing. From my perspective, are you familiar with Lua or Tickle?
No, but how does that work? Like, are they like linking like object files together, like, and just
No,
having it all run as one binary, or is it like FFI?
yeah, no, they're not precisely linking everything together. I'm not super familiar with Tickle. What Tickle is insanely dynamic, so whatever it does,
Mm,
it's insane. But I can tell you about Lua because that's what I have more experience with. Lua, generally speaking, gets embedded into other systems, like Redis has Lua, Nginx has Lua in it, and I think also games maybe from Bethesda has the game scripted as Lua. And the idea is that Lua specifically runs in a virtual machine. So Lua gets compiled to bytecode and the virtual machine runs the bytecode. So it's platform independent. And you have
oh,
the virtual machine being specific to the
cool.
to the machine. But if you forget for a moment the implementation details, the idea is that the role that Lua has in games, more specifically, apparently World of Warcraft also uses Lua. So the idea is your you know what? Let's talk about Fallout maybe and Bethesda games. Like in Bethesda games and Fallout, you have a complex storyline and you have a lot of high level stuff that doesn't necessarily have to be written in C. You can script it in
Right.
Lua where it's much more easy to make changes over time and do stuff. And the idea is that then Lua becomes the control plane in a sense, like sits on top of everything. It doesn't have to be amazingly performant. Sure, there are trade-offs to make, but the idea is that it's not doing the heavy lifting. It's not like computing, I don't know, lightning and stuff and collisions.
Hmm.
It's just driving the super high-level mechanics. And I think that people were describing Rock as having potentially a similar role in game development, with I guess the difference that by virtue of being a functional programming language, maybe you could pull off certain types of speed improvements that you cannot pull off with Lua. Although Lua probably, I'm just throwing these ideas around. I have no idea how much of this is concrete stuff, but Lua, generally speaking, is people like to embed it because it tends to be very lightweight. That's why people like to embed it. It's a small language. It doesn't have a
Right.
lot of overhead, but at the same time, you can have mods um, in Fallout and stuff that completely destroy your game performance, and
Right.
that can also happen with Lua. So maybe there are some things that can be pretty cool if you, instead of bailing out of native compile speeds just to have a nicer scripting language, you could still have both. Like in a sense, it could be like you have your cake and eat it too,
Right.
because everything is
Exactly.
compiled, but it's also high level. I don't know. That's a cool way of thinking about stuff.
Right. So I think that's a good observation and a good comparison. So because it definitely feels the same, but the implementation details are completely different. And because of that, I think if it were something like that were to be done in Rock, it'd probably be significantly more performant. And you wouldn't have to worry about like writing a Lewis script that slows the whole game down, right? Um, so so yeah, I think it feels similar, but uh, luckily the implementation is different, and it could
Hmm.
probably be better. So yeah, that's cool. That's a
Yeah,
good
awesome.
observation.
I think there's another. I guess the very interesting part about all of this that comes to my mind is also that there are some moments where you want to deal with the machine. Maybe this is not a point of view shared by most people in the Z community, because I believe most people tend to have a more low-level systems programming point of view over things. They care about the machine and pulling and pushing the levers. But from a more general computer sciencey perspective that I think I have, to me it feels very intriguing, the idea that you are splitting what is stuff that has to deal with the machine and stuff that you decide that doesn't have to deal with the machine, and then you express in a pure functional programming language, which I think it's it's super nice. Pure functional stuff, it's super fucking nice when it doesn't clash with the problem of computational speed. But there are a lot of things that you can pull off with functional programming languages that doesn't really work with imperative stuff, and I guess vice versa. So I think splitting along that vertical is very fucking cool.
Yeah, just like you said, having your cake and eating it too, right?
Yeah. That's awesome. Let me think, is there anything else that I can read from chat? Okay, people are just discussing among themselves now. Awesome.
They're discussing what?
Yeah, they're discussing about the comments from before. It's fine. You know what? By the way, you can check out chat after we're done here. Don't worry, you're not missing out on anything. You can just pull up the VOD and read everything. People only have good things to say about the talk.
Cool.
The thing that I would say in conclusion is that I lied. I think I know what monads are. And honestly, sometimes it happened to me that I wanted to have something like this, but the language never had carrying. And without carrying, in my opinion, what's the point then? And fuck it, I approve it. Let's get rid of monads.
Cool. I'm glad we have your seal of approval.
To be fair, I haven't written much Haskell code. Very little. I'm a Lisp guy when it comes to functional-ish stuff.
Most of my functional experience is actually with Elixir. Sorry, go ahead.
No, nice. And I think we have a nice integration story there too with Elixir. Have you checked out Ziegler?
Oh, yes. Lovely project.
So that's cool too. Lucas, if you have anything else, I guess that's the time. And maybe you can tell people where to reach you, or I don't know if you want to make friends, or you tell me what you want to say. And after that, I think we're gonna call it.
Cool. Yeah. So I mean, I'm always in the Zig Showtime Discord, and then in the regular Zig Discord. I'm also in the embedded one, but I'm not so useful there. And then if people go back and watch this later, I had one of the early slides has my Twitter, website, email. If you want to email me about stuff to work on, I'm always down. I just left my day job to focus on my own company and Rock full time. So
wait, so Rock is used in production?
No.
What?
I'm not using Rock at my company yet, but the second I can, I will.
Okay.
Yeah. And then I put a slide up. I don't know if people can still see the slides right now.
Yeah, they can.
Okay. So there's my Twitter and GitHub and my email. Feel free to bother. You can message me wherever.
Okay. Do you think you will be the first person to have an opening for a Rock job position?
That would be cool. I don't want to arrogantly say hell yeah, but if I can, I will. And yeah, if I can, I will.
Awesome. Well, Lucas, thank you very much. This was awesome. Also, people, feel free, if you have any extra comments about any of these talks, the Zig Discords and the RC channel definitely are places where you can go chat more about this. But there's also the Zig forum, and it's zigforum.org. And if you go there, there's a section dedicated to the Zig Showtime, and I create a new thread for each episode. And I guess that's a better place than YouTube comments where to entertain a discussion. Let's just put it that way. Much better place. So thank you very much again, Lucas. And I guess see you soon, maybe with another Rock Talk. What do you think?
Oh yeah, whenever.
Nice. So everyone, it's been a pleasure. Super long episode. Sorry, that's how the cookie crumbles. See you next time.